Ladies and gentlemen, let me introduce myself as well. My name is Tomáš Havlíček, and I will spend next few minutes together. I'm working on a position as a CAE product manager in SIMCENTER company. Now it is almost 12 years, and I hope we can change our knowledge together in this webinar. But let me start, please. Only for the beginning, let me please set up some rules of this webinar. I would like to speak continuously without interruption, but you can of course ask me your questions through the chat window, and please use it anytime. I think Lucas will help me to not to forget anything and answer all of these questions at the end of the webinar.
Of course, yeah.
So I guess this is the time to start. Show must go on. So the agenda of this webinar is, at first, let me introduce new computational fluid dynamic analysis solution, SIMCENTER FloEFD. I explain to you how does it work, what does it do, and I will show you most used application, introduced advanced add-on modules, and at the end, some nice customer stories. So the first introduction. FloEFD is a fully CAD-embedded CFD software solution that is used for analysis of heat transfer and fluid flow design challenge. You can see EFD. EFD stands for Engineering Fluid Dynamics, as there is no need for advanced numerical scales as in traditional computational fluid dynamic tools. And the key features of FloEFD are intuitive user experience. So it means that there is very short learning curve. Use of native CAD data. It means that there is no translation or fluid body creation needed. Automatic recognition of model change, so geometry and simulation data are synchronized. And it's very fast automate measure. There is a fast and easy smart cell meshing. I will show you what does it mean later. And also FloEFD, there is very unique solver, and you get accurate result very fast, even for highly complex geometry. And the last one key feature is that there is powerful parametric study and design comparison functionality for easier what-if analysis. We will now look at SIMCENTER FloEFD. The first are the CAD-embedded nature of the product. We have seamless integration with CATIA, PTC Creo, and also with Siemens NX and Siemens Solid Edge. The benefits, there are direct use of CAD geometry, automatic detection of fluid region. And the real benefits of this is that there is no translation or definition of region within a CAD model. Any CAD design changes are instantly reflected in the CFD analysis. Synchronization of CAD and CFD becomes a non-issue. And there are also the second standalone product possibility of FloEFD, so it doesn't matter what CAD system you use. Maybe some differentiation between FloEFD and traditional CFD systems. There are no claims for requirements for numerical knowledge, manual meshing, or some skills of programming instead of traditional CFD system. And on the other hand, the FloEFD is suitable for fast design cycles and easy to use. And it is also important to compare in terms of time in the product design cycle. Here you can see how convenient it is to use one environment for both design and simulation. What does it do? Or maybe better, some FloEFD capabilities. It's really a full CFD system. So there is heat conduction in fluid, solid, and porous media with or without conjugate heat transfer. There is subsonic, transonic, and supersonic gas flow, hypersonic air flows, radiation heat transfer, volume and source heat sources, condensation of water from steam, free surface simulation, water film evaluation, it means surface condensation or evaporation, or melting and freezing. Joule heating from the direct electric current, fluid flows with boundary layers, including wall roughness effect. We can compute compressible and incompressible fluid flows, steady state and or time-dependent fluid flows, and also we can calculate with a cavitation in water or other liquids, free, force, and mixed convection, combustion, two-phase flow, laminar and turbulent fluid flows, and also we can choose flows of non-Newton liquids. It means liquid plastic or honey, blood, etc. And internal fluid flow. In the next slide, I will explain a lot of this functionality. Maybe on the next slide, I will explain you how does FloEFD work, or maybe some workflow. You have opened the assembly in your SCAD, then you can save as an idealized geometry, or you can work on the production assembly as well. You start and set up the analysis per FloEFD toolbars. The mesh is automatized and you can refine it during the solving. The evaluation of result is still in unified environment of your CAD system. And then you can apply new boundary condition or edit geometry and run the entire study quickly again. You can use comparison studies between themselves or use optimization process to find desired parameter. The summary, FloEFD is embedded fluid flow and thermal simulation in your very well-known environment. There is a fast and automated meshing, and you can compare some configuration, parametric study, model optimization, and FloEFD is really intuitive and easy to use. It's designed for non-CFD experts, and there are special features by FloEFD modules. I will speak about it later. Maybe you are afraid to professional mesh settings, but how I said before, this part of workflow is fully automatized. As mentioned earlier, FloEFD utilities a Cartesian meshing system, which is well defined and robust. You can see it on the picture. There are three types of grid cell: fluid cell, solid cell, and SMAR for the various region in the model. The higher mesh resolution is achieved by octree meshing, which allows grid cells to split into 8 smaller grid cells, and this can happen up to a maximum of 9 times. So smart cells are the key of SIMCENTER FloEFD technology, and what differentiates us from our competition, this will be explained in the next slide. Look at the smart cell in more detail. This is the basic of how they operate. There is also always a smart cell between fluid and solid, because this is where the wall of geometry is, and therefore where the boundary layer is. This allows for a structured mesh around the geometry without the requirement for a special boundary layer mesh. Smart cells simulate the boundary layer without these requirements of a fine grid at the wall. Thin and intermediate boundary layers can be the same size or smaller than the grid cell size and still get a physically correct result. Where there are multiple grid cells within the boundary layers, these are threaded as a thick and use the same technology as conventional CFD to solve the physics. One of the most powerful aspects of SIMCENTER FloEFD is the solution adaptive meshing capability. The mesh will refine itself during the solve to add additional grid cells where the high flow gradients are detected. This is something very few codes can do, and it's a result of our unique meshing schema. This is an automated process and requires very little user input. The solvers will continue from when the refinement occurred, interpolating the result on the new mesh. The benefit of this technology is that the complexity of gridding is removed from the user. They don't have to be a meshing expert, which is critical of most traditional CFD tools. Analysis of fluid dynamic is required to support many aspects of product design across many industry segments. Today, it is not just about using in automotive and aerospace industry, meaning also falls on other industries like electronic, consumer products, industrial equipment, HVAC, and process industry. Let's look for some examples of industries. The first industry example is electronic, and simulation aside with the fans and cooling equipment, heat sinks, heat pipe, liquid cooling, PCB design, power electronic, vents, LED lights, and lighting and display. I think the FloEFD was based on this industry, and they are very well at this functionality of electronic cooling. The next important industry example is process and industrial equipment. In this industry, companies usually simulate pumps, burners, fans, valves, boilers, filters, meters, pipes, oven, and of course heat exchangers, and the other devices you can see in the picture. This is the very important and big industry. Now I would like show you some technical using. The first is the calculating of a pressure drop. There is a full list of application for pressure drop. It's using for device flow coefficient determination, extrusion process optimization, jet pump dimensioning, filter efficiency, pump efficiency, fan curve determination, HVAC ducting sizing and placement, and a lot of other using. The next application types is mixing process, the full list of heat transfer application like heat transfer, electronic cooling, heat exchanger efficiency, injection molding device cooling, sterilization in food process, rubber extrusion, windshield de-icing, solar towers, lighting, solar heating, and others, and many more. The next application types is mixing process. You can see typical application, and you can also use it for mixing, for example, hot and cold water or fresh and dust air. or other application. The next types are flow fields. It's a lot about aerodynamic testing, cavitation prediction, intake and exhaust manifold design. This is connected with force prediction. Typical applications are in aerospace, in aero industry, and also automotive. You can find aerodynamic coefficient, wind load on surface, on the structures, thermal stresses, and you can gain some forces from the pressure. Next application is in electronic industry. The primary goal is choose correct fan sizing to overcome system pressure drop and ensure the fan operates on the correct part of the fan curve. Local flow feature resulting from fan swirl can have a drastic effect on local cooling, and fan interaction can impede fan performance. The next is electronic industry application. This is about airflow optimization. The primary goal of this analysis are select the most suitable heat sinks for a specific application to minimize cost, weight, and pressure drop, whilst meeting temperature performance criteria and minimize wake effect that caused the distribution of the downstream airflow. In the electro, also there is a next goal. We can ensure temperature limits that are not exceeded and prevent dust ingress. Now we can change the industry to process industry application. It's about also heat exchangers. The primary goals are analysis of flow distribution problems, detailed analysis of specific areas like flow distribution, plenum chamber, simulating application for which no empirical dimensioning program exists, some transient consideration, calculation with boundary condition that lie beyond the empirical specification, evaluation of operating point that differ greatly from the design, evaluation of pressure and temperature for further use in stress analysis. And you can reduce size and optimize performance of impeller design, predict characteristic and efficiency curves, design
cavitation, noise, and pulsation, reduce power consumption, understand complex flow behaviors like influence of inlet and outlet ports, visualize details of the flow structures, detect recirculation and flow detachment, or predict mixing efficiency, or optimize impeller design. You can also use calculation which may reduce size and optimize performance, minimize pressure loss, avoid cavitation, predict forces on the valve, for example, minimize wear and increase valve life, and understand complex fluid behavior like visualization flow versus valve position. The next of the process industry application is connected with pipes, ducts, and stacks. You can reduce size and optimize performance, determine pipe losses and flow resistance, optimize shape, optimize use of baffles, design out cavitation, optimize mixing, and for example, minimize power requirements. Now we can jump to automotive industry application. The primary goal of this analysis are improve aerodynamic of the car's chassis, drag and lift coefficient, fuel consumption, flow around parts such as mirrors, for example, brake cooling, underhood aerodynamics, air intakes, external flow of exhaust gas, window and mirror cleaning, or some thermal design of lighting element with for example, special module, add-on module, LED. You can also analyze and improve flow performance and thermal behavior, flow rate distribution, pressure drop, some transient simulation, temperature distribution, some test of manufacturing option, for example, or tests packaging option. There is really a lot of opportunities. Some next from automotive, next application with primary goal, analyze and reduce pressure drop. It's determine high flow rate or low pressure drop, some dangerous for cavitation, safety regulation, and as I mentioned before, designing of headlight, so we can determine suitable material for manufacturing according to temperature limits, simulate solar load onto lenses with focal point position, analyze whole headlight thermal management, improve some evaporation speed of the film condensation, And you can also simulate some special component, like analyze LEDs on PCB and heatsink performance, optimize PCB and heatsink design and material, and determine how spot of lens modules for temperature and location of the hotspot. We can look on some climate control. The primary goals is in cabin modeling, analyze climate control functions and passengers comfort. This is possible in our special add-on modules HVAC. It's important to meet health and safety requirements, windscreen de-icing or defogging, passenger comfort under various conditions like harsh. And with the HVAC duct and fans, you can analyze and improve the flow field in a vehicle, heater systems like airflow pattern, flow distribution, pressure distribution, optimization of fan blade and volume geometry, calculate fan performance. And now we jump to aerospace industry. It's very specific, but we can simulate a combustion. So there is some fire suppression applications with primary goal understand and propagation of the flame within a contained environment, understand flame shape and temperature, and for example predict some combustion products, run as transient to understand how long the mixture will burn, and the associated peak temperature. The next from aerospace industry is hypersonic flow task. The primary goal is analyze and improve external flow. It means you can optimize aerodynamic coefficient, determine forces and moments, predicting stability or predicting cooling efficiency. And now I will introduce FloEFD add-on modules. FloEFD comes with 5 add-on modules for specific application or special physics. The first one is LED module. It's specific for lighting with LEDs and any type of bulbs and condensation and icing modeling, include also water absorption in solid. The next add-on module is electronic cooling. There is a specific database and feature for electronics cooling application, like a special library of electronic equipment. The next very important module is HVAC. It's for some special analysis of comfort parameters. It's for designing of heating, ventilating, and air condition. There is some specific building materials and these comfort parameters in this HVAC application. The next module is EDA bridge for import of EDA data from compact to XSplit PCBs and Delphi model. And the last module is advanced, and it's really for advanced physics such as hypersonic flow, gas combustion, condensation and icing, and water absorption in solid. And what module will bring you added functionality? Sorry, this is correct. HVAC modules also offer to you library of building material, which are very important to accurate simulation of heating, ventilating, and air conditioning. The electro modules edit functions for cooling. LED modules, there is, for example, advanced radiation model, library of LED chips from the producers, and also condensation as the same as in advanced module. In EDA bridge module, there is a translator for import 3D data from many ECADs. And at the end, the advanced module for very special use like condensation, icing, hypersonic flow, or combustion. So you can see the table with this possibility of added physics. But we have to emphasize that most customers are rich enough with the basic FloEFD software because there are almost important and most used features for thermal and flow management. Now I would like to show you some customer stories. The first stories is from Robert Bosch company. It's about automotive steering. One of the customer success stories is the case of steering double valve optimization using CFD tool FloEFD, developed by Robert Bosch company. And they says thanks to FloEFD tool, time required for developing new part has been significantly decreases. At the same time, pressure drop was lowered by 20%, which leads to energy as well as cost saving. So you can imagine how many prototypes would have to be manufactured in order to achieve such parameter without simulation. The next one is e-cooling from Germany. The SIMCENTER FloEFD was used to determine the flow distribution within the enclosure of frequency converter. And based on simulation result, design modification has been performed in order to achieve equally distributed airflow and thus prevent overheating of a particular component. And thanks to simulation, tight project deadlines were met with long life guaranteed. The next customer story is from Pan Asia Technical Automotive Center. The task was to improve passenger comfort in a car, and thanks to easy to learn software, even engineers and designers could perform simulation to perform the design. Embedded parametric optimizer was used to achieve an optimized design. FloEFD simulation results were confirmed by digital twin testing on real physical model. Overall cost for development has been significantly reduced also. At well-known Bosch company, the FloEFD was used in order to manage heat transfer in PU with a liquid-cooled plate. And thanks to simulation, best design was found easily, and therefore the company stayed ahead of competition with time, cost, and quality improvement. And what the main engineer says about simulation, the increasing demand in thermal management requires a recognition of the product development process and the introduction of an increased number of simulation steps. The next one is Black & Decker's default equipment, and they use FloEFD to simulation, which helps them to test design in many variations for venting, fan positioning, and geometry, as well as housing changes. And in this case, FloEFD helped to the company to work on contracts with involved very complex geometries, such as stator coil and turn support system of a 20 megawatt electric engine. And thanks to FloEFD, the best possible cooling for the component was ensured. And next one is famous Japan company. They are focused on electronic devices. For these devices, they use the FloEFD to assist in the challenges the team faced with the design of semiconductors in projectors. And without simulation, they could hardly guarantee device reliability, and head of R&D says semiconductors could be easily damaged by inefficient cooling, thus excessive amount of heat. And I have I think last two success stories.
This one is very funny. It's the CFD tools find application also in athlete engineered technologies such as Brownlee baseboards, and thanks to simulation, precise seconds can be saved in several sports disciplines. And the last one, finally, Grass Valley company that produced professional camera. They say that they have much more insight into the heat flow within the camera and have been able to make numbers of changes to the design very early in the project that would have taken much more time to make later on. For example, on the bottom picture can be seen a significant difference of two different camera design achieved by using FloEFD. We are targeting to the end, so I showed you some FloEFD value proposition. It's a comprehensive solution that covers most fluid flow and heat transfer design simulation, allows you to solve your fluid flow and heat transfer issue and optimize your design early in the design process. The FloEFD is designed for use by both designers and engineers who are not specialists in CFD, and also it's possible to use for CFD specialists. Why not? In FloEFD, there is no need to specify the parameters when design is changed. You simply rerun the analysis and display the result. SIMCENTER FloEFD is an award-winning, well-validated, try and proven solution to front-loading of CFD with 25-year commercial pedigree and a large installed base. SIMCENTER FloEFD has demonstrated engineer productivity gains of 2 times to 40 times versus time consuming with the traditional CFD approaches. SIMCENTER FloEFD is now available for our both Siemens CAD, NX, and Solid Edge, like multi-CAD embedded version following the recent acquisition of Mentor Graphics. It was a rush time, don't you think? Anyway, I hope you enjoy your time together. And now we can go to your question.